Right. Hello again, everyone. Uh, Let me pop up the chat window. Then we can begin. All right. So far we installed a cluster, configured it. It has networking. We implemented some security policies. However, we didn't talk about how to write these policies. We just went through the motions of applying such resources and what are the implications after you apply one. But today, we're gonna explain what will happen when you are trying to figure out network flow, how you can figure it out, what are the tools that are at your disposal with Calico, and hopefully bunch of mistakes that I make during the presentations. So if you're up for it, let's see what I can figure out and what I can miss. All right. So, as you know, I've been using Multipass. So what I need to do is, so here is my Multipass. I've got a control node, a worker node, and a private repo. So because I'm going to lock down this cluster very tight, there is not going to be any outgoing traffic to the internet, and only things that I specifically permit would be allowed. One of the things that I usually have problem with is port 443, which is HTTPS, and usually we tend to allow outgoing traffic to it. However, I don't like that sort of policy. So in this cluster, I'm going to show you what will happen if you lock down everything and even block HTTPS, and how you can actually pull it off by deploying your private repository. Again, I'm getting ahead of myself, so let's just transfer the key, export it. So hopefully I don't mess up another cluster somewhere. I think this should work. And nope. What did I do? Oh. That should work though. Where is it? Doesn't take. Oh, PWD. I'm using capital. No. All right. Kukel config view. It is. Oh, it's still trying to. Oh boy. I need to change the IP address here. So what is the control IP address? All right. I need to. Yep. All right. Now it should work. Yes. All right. So this is the cluster. If you remember, we got two participating node. One is the control plane. The other one is the worker node. Now I did create a bunch of policies. So let's look at final allow everything. All right, so here, I'm using two allows and an order number, which is fairly big. So throughout the packet lifespan in our cluster, it will get matched with a bunch of policies. And at the end, because of this order number, it will come across this policy. Now here, we're trying to permit everything because at the moment, we're just craving the foundation for our policies. So that is why it's there. Now, quickly, I need to copy paste something. All right. All right. So at the moment, we're just copy pasting policies. These are policies that I created beforehand, and it used to work. But let's say something new happened, and we need to figure out a flow and then write a policy for it. Now, what can we do in that situation? Well, that is when you can use the log action and create a policy that logs everything that happens in layer 3 and 4. Now, keep in mind, again, coming back to the orders, a log policy will log everything. And after that, because we added a policy, everything will be dropped. This is the default behavior of Kubernetes. When you have your policy engine, doesn't matter what, it usually everything is permitted by default. But after you add a policy, doesn't matter, ingress or egress, then that policy behavior becomes whatever you specifically identified as a permit or deny, then an implicit deny would be added at the bottom. So by default, by just adding a policy, you are turning on the default deny. However, since network policy in Kubernetes is namespaced, you need to go over every namespace and add a policy there in order to enable the default deny. Now here with Calico, you can use global network policy to just write one policy, a single policy that denies everything. Now I'm using the same behavior to log everything. Now you might be asking, great, we have a log. Where can I see it? Well, that is when we need to log into one of our instances and tail a few files. I believe it is in syslog. Yes. So right now, nothing is happening. I need to generate traffic. So how can I do that? I need to kubectl get pods. Let's go kubectl rollout. You know what? We can actually do something else that would prompt the log portion out very quickly. So it would be, there was a multipass exec. Yeah, so multipass exec node 1, then do, I'm not sure if it had, but let's try it. Tail, there, log, it would be message. Did it work? Nope. Is it messages? Where is, oh, syslog. So syslog. All right, and I need to put that in the background. Oh no, I need to put this thing in the background. And sorry, this needs to stay here. You know what? I'll just add another window. And monitor this thing here. All right, so coming back to our adventure, now let's go ahead and restart something. So in my daemon sets, restart. Let's go Calico node, see what happens. It needs to be in Calico system. All right. So a bunch of things happen. At some point, wait a minute, did I install syslog in this thing? All right, so multipass. What is going on here? We do have our syslog. Did I add? Yes. So describe. It's a global network policy. It's gonna log everything with the order of big number. And the other one is going to happen after it with even bigger number that allows everything. Oh, this looks fine. Let's just multipass control. I feel like I didn't install something in here. Let me check. All right, so it looks like the IP tables cannot log output logs in here, so I need to go back to my notes and figure out what is the thing that I'm missing. So in my projects, what was it? Image. project, image security. Could have something around here. All right. No. What are the things that I enabled? Log is happening. Oh, all right. So I need to do something else, which is, all right. If you remember, I talked about host endpoint policies. So by default, everything that happens inside the namespace, and things like your network cards and host processes are not part of the traffics that you can manipulate. Now, what we can do to aid that situation is to enable host endpoint policies. By enabling that, you get the option to use one of the selectors. We'll come back to that. One of the selectors or labels that your nodes are associated with, and try to tell Calico Policy Engine to actually enforce some sort of security for that part. When you do that, hopefully you get the Calico packet output. Now, all right, first problem solved. Actually, second problem is now solved. Now let's get back to the log. Now, this log is very simple to read. If you have worked with IP tables, I think you will know it by heart, given that IP tables have been around from, I don't know, 90 something. I'm assuming most people know it. However, to give you a brief overview, these fields are corresponding to stuff that you have in your cluster. For instance, this packet is an outgoing packet. How do I know it? Because it has an outgoing, but it doesn't have an interface for incoming. So ingress, it has nothing, but the egress is my loop path. Now, what is the actual communication? Well, source local is trying to talk with with destination local. Now, that's a bit odd, but we'll get to that. All right, so these are a bunch of TCP things that hopefully we don't get into it, but the protocol is TCP. All right, I kind of know how to write a policy to target this one. But the other part, which is important, is destination port. So what this packet flow is telling me is that I have a traffic flow, it is outgoing, and it is happening inside the control node. So outgoing packet, control node, and a local host is trying to talk to a local host process on port 9099. All right, so let's figure out who uses that. If you come back to your netstat ss, whatever tool that you like to use in order to figure out what is happening with your networking part of Linux, you should be able to figure out which process or processes are using that port. Here, it seems like Calico node, it seems like something is trying to talk to Calico node. Now, port 9099, I kind of know it is for health check. So what we can do next is to write a policy that can target this particular port. All right, so I think I have the policy here. All right, so let's write the policy for this one. Now, the policy would be something of global network policy nature, because this is happening again inside my host processes. I want to select one of my nodes or both of my nodes or how many nodes I have and tell them whatever is happening and it's whatever is happening when it wants to talk to the host processes, the local host processes, allow it. Now, how I can do that is by I can use an order number, which is less than our log and the allow action, because we want to permit this one, so it needs to happen before those other ones. Then I would say if it's an incoming to the local host, allow it. If it is outgoing from the local host, allow it. Now, it's a little bit of foreshadowing here because the ingress part, the traffic that we talked about, was just egress. However, if you look at the traffic again, there should be an ingress. All right, so here, there was a destination port. So here is the incoming and here is the outgoing. Now, we'll come back to this later, why this is happening in such a way. But again, most TCP traffics, when there is an incoming, there will be an outgoing. It would be pretty odd if you don't find one for it, unless it's like a thin packet or something. Anyway, getting ahead of myself again, so let's come back to our policies. So let's talk about the policy. All right. This is the best drawing that I could muster. In this cluster now, ingress and egress from Calico node should be allowed, should be permitted to the host OS. And if we come back to the terminal part, unless the demo gods are trying to pull a prank on me, we should not see that particular packet anymore. All right. Seems good. Yeah, all right. So one more thing. At the moment, I'm in the control plane node. Now you can do the same thing in your other nodes, and actually, I think it would be better if yeah. So doesn't matter how many nodes you have, you can go into each one and figure out what packets are hitting your policy, your log policy. Again, same thing. This is an egress packet. It is going outside of your cluster. and it is trying to hit port 80. Now, we'll come back to this one and make it stop. Anyway, for now, let's go back to our policies. All right, so Calico node can now talk to the host. What is the next thing that we need to do? It will be, sorry, I need to look at the policies that I wrote here. I've got a log, I've got a deny. All right, so for some reason, oops. I need to permit this one. So DNS, I think I deleted and recreated this cluster. That's why I have to write some of the policies again. Yeah, permit DNS. Oops. Delete. And you can actually interact with all these policies, these Calico policies, with kubectl. All right, already exists. Good. So I've done this one. I've done this one. All right. So next component. Did I do this thing? Oh. Create. All right, it already exists. I assume I talked about it too. But anyway, again, order is lesser than the bottom policies, which is log and like permit everything. Selector is for API server, Calico API server. It will be Calico API server as it's written there. And what's going on here? Get pods in this thing. All right. So there are two pods. These two pods are actually the thing that is allowing you to write Calico policies. So Calico policies are living in this API group, which is projectcalico.org-v3 or v1, depending on what is that you're using or the configuration or the policy. But anyway, on its own, kubectl doesn't have access to that API group. Since Kubernetes is extendable, you can actually extend it by creating here an API server that adds this API group and API tree to the resources that kubectl pulls from the server. Oh, there is no. What did I do? Kubectl API resources. All right. So if we look somewhere around here in this mishmash of things here. So API server is the one that operator installs, and the CRD will let you communicate API server operator. So this CRD has the custom resource definition that allows you to interact with Kubernetes with Calico API group. Anyway, let's go back to another policy. Did I run this one? What is this one? Oh yeah. All right, so next one. All right, what is next? Next, there is this policy, which is a network policy. Now, I'm getting out of the whole cluster, controlling the whole cluster, and I'm zooming into each namespace because I can secure the cluster with one global policy that says deny everything. But then I need to go into each namespace and say which things should be allowed. I need to be very specific about my needs. So here, I'm trying to say Calico Cube controllers, which is a pod that fetches information like number of pods that are running, how many policies you have, some sort of statistics that you can use with Prometheus. Again, foreshadowing. Calico Cube controller does have a way to expose Prometheus statistics to your monitoring solution. We'll get to that in our next sessions. But again, here I'm trying to say if Calico Cube controller pod tries to talk to Calico API server pod, well then bless it. How it would look like? It would look like something like this. All right, so this would be. Oh, all right. So in my cluster, if inside a node and inside the Calico system namespace, if something tries to, if Calico Cube controller pod tries to talk with Calico API server, let it happen. All right, next one is Calico Cube controller. Actually, it was this one. So, no. All right. Oh, one more thing. So that is for Cube controller inside a node. But what happens if your Cube controller pod tries to talk to API server, or in that matter, any sort of Calico component tries to talk to the API server from another node, from a worker node? Well, for that, we're gonna need a global policy because you are trying to get out of your namespace, go to a non-namespaced resource, which is now controlled by a host endpoint policy. So for that part, we create a global network policy with a selector that looks for kubernetes.io-os/os, and the destination is the port that Calico API server responds to with the protocol. Now, if you don't remember, I talked about this thing, but if you are new to the stream, here is how I figured it out. Because I have the host endpoint enabled, I can use these labels to target my nodes and their interfaces and their IP addresses, which are not possible with Kubernetes policies. Now, for this specific one, I'm using Kubernetes IOOS. So regardless of what operating system I'm running on, if my node has a key which says kubernetes.io/os, then this policy would apply to it. I just realized I need to change to here. All right. So again, so in this policy, regardless of what is happening, if there's a node that has the kubernetes.io/os label, then this policy would apply to it. Where did I get this selector from? I took it from the labels. Will that work normally with Kubernetes policy? No, because here we enabled Calico endpoint, host endpoints, which allows us to actually write policies for non-namespaced resources, such as your node network cards. Anyway, let's get back to the explanations. All right, so components are done. Now, next one. So one thing that is very important is the Kubernetes API server. No matter what sort of CNI or plugin or workload you install, if they want to know something about the inner workings of your cluster, they need to communicate with the Kubernetes API server. Now, most of the time, the Kubernetes API server is running on port 6443 or 443. It is usually, actually, hopefully it's using SSL, so it can be encrypted, but it usually happens on an HTTPS sort of protocol, and Kubernetes API server will answer to whatever workload or component is trying to communicate with it. Now, we need to tell our policy engine here that if a component or workload, or if a traffic flow wants to either be incoming or outgoing into my nodes, and if it's targeting the port 6443, which is Kubernetes API server, and if it is from the control plane host, let it work. Now, why we are targeting control? So here, the intention is to allow worker nodes to talk to the Kubernetes API server. Now, that flow would be a worker node sends an egress traffic out of its network card, and it becomes an incoming for the control plane. So incoming for the control plane, outgoing for the worker node. And again, the order number is less than what we have at the bottom. All right, so next part. This is how it would look like. All right. So inside a cluster, if a worker node sends a packet to my control plane node, it would be perceived as ingress. If it's outgoing, it would be perceived as egress. All right, next one. I need to change the terminal. All right. So next one is a policy Oh no. All right. So next one is a policy that let us so for this to make sense, I need to show you something. All right. When you install, let's say, CNI, it will give you some sort of features, and some behaviors are imposed in your cluster. For instance, if your pods are trying to talk to the internet, then they will be source netted outside of your cluster. For this to happen, the mechanism that allows this to happen is actually a config inside your IP pool. So here I've said, or actually with the default one, I've said that the CIDR, which is, I'm assuming, yep, it's my pod CIDR. So what I'm saying here is, no matter what happens, if a traffic is coming from 172.16.0.0/16, then that traffic needs to be netted outside. And that is why your pods can talk to the internet. Now, if you're trying to secure your cluster and like plugging every hole that you have in your security chain, then it becomes it becomes impossible for your pods to talk to internet or use the source net. So in order to allow them, what we can do is we can write a specific policy that says, if there is a component that is getting source netted, then allow it. Now here, my intention is not to allow anything to talk to internet, but I'm trying to target Calico Node, Calico API server, and Calico Typha. And I want to say these components, if these workloads, these pods are trying to communicate with the control plane, then and Kube API server, then let it happen. So next one is going to be Typha. Now, in my first session, I talked about Typha. But anyway, here's a quick recap. Typha is a component that sits behind Kubernetes API server and Calico. What it does is it will talk to your etcd database. It will take all the information from Kubernetes API server and create a cache from it. Now, if you have like 10,000 nodes, 5,000 nodes, a massive number of nodes, then instead of all of them talking to Kubernetes API server, the Typha will come in the middle and serve all your Calico installations. Now, that would have a significant performance boost because your Kubernetes API server is surely busy with answering all other questions from your other components. Anyway, so here, again, using that node label, because this is the host endpoint policy, I'm trying to say, if there's an ingress, which is using TCP, and it's going for my control plane node, let it happen for this port. If there's an egress, again, if there is a TCP incoming, then there will be a TCP outgoing. That's how TCP works, usually, unless it's a FIM packet. But anyway, that is how. Actually, if you deny one of them, the TCP will just like send the packet again and again until I give up. So next one. All right. If you remember, there was a private repository. Now I'm trying to lock down this cluster. So by locking down, I can't even talk to my registry, like private registry. What I can do is I can actually create a policy with a CIDR 192.168.122.104.32 and the port that my private repository uses. YAML. What a fun experience. YAML. All right. Yay. I figured out how YAML works. Anyway, so it's the worst thing to write YAML when you are trying to talk, but I've done it somehow. Anyway, so kubectl get GMP. What was the YAML? What I was talking about. All right. So I specifically use the IP address for my private repo and said, if something is trying to talk with port 5000, let it happen. Again, foreshadowing, but if we come to private repo and do here, there is a service on port 5000, which we'll use later. Actually, we used it on session 2. So if you want to see that action, check it out. So host endpoint. All right, now hopefully I should be able to delete everything. But I need the logger. Let's do tail F here. Okay, here is a tail 2. All right, what did I just do was I got rid of my global policy. Actually, I got rid of 2 policies. One was the final allow everything, which was letting everything talk to everything else, no matter what was the outcome. And the other one was the log. So I'm gonna put in the log again and here. So right now, everything is working unless it's here 1, 2, 3. I think it's NTP. Yes. So everything should be working in my cluster, and everything should be secure because I specifically wrote what is going on. Now, one thing to mention here, as much as it's fun to watch me go over terminals in a live stream and getting things wrong, it is never a good experience to like log into, I don't know, 10 nodes or 5,000 nodes to figure out what is happening. So what can we do about that part? That is where FluentBit comes in. So if you don't know about FluentBit, it's an application. Let me just, what could be better than their website? So FluentBit. All right. So FluentBit is an end-to-end observability pipeline. Super fast, lightweight, and highly scalable logging and metric processor and forwarder. So what are we gonna do next is, actually, let me figure out what are we gonna do next. So here, apparently, FluentBit has a Kubernetes installation manifest. So let's use that and install FluentBit. And then administration networking is nope. Pipeline. Okay, this looks interesting. And then we can actually input kernel logs. Everything works. So we either use kernel logs or syslog. I'll bet it would be syslog to send out these. Where is it? To send out these packets and aggregate them in one place, one centralized data store or a database or something. So need to come back to FluentBit. All right, let's say we figured it out and send it out. Okay, it's gonna be output. All right, so choosing from here, actually, Kafka, Loki. All right, so for this part, I'm gonna need your help. What would be the output that you like to see? Let me know. I'm thinking about something like Loki. Grafana Loki would be cool. Or Elasticsearch. That would be cool as well. So these are the two things that I want to explore in our next session. We can actually have some fun with Slack too. What is this? Yeah. All right. So for the next session, the saga will continue, and you got 7 days to let me know which one of these would be the output system that you like to see. Coming back to my guinea pig of a cluster. As you can see, nothing is happening, which is good. No packet drops, nothing. So everything that needs to talk, every component or workload that needs to talk to something is now actually doing it. These are my policies. I do have some other policies here. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 policies. So 10 policies to achieve everything. You could mix and match some of these depending on your environment. But anyway, this is how you secure a cluster. What we got like 3 minutes, so let me talk a little bit about selectors before I let you go to try your own journey. So if you come to the docs website, what is that B doing? Oh, it's eBPF thingy. Oh, by the way, use Calico eBPF data plane to enhance your Kubernetes networking performance. If you'd like to know more, come to our docs and click here. But I'm getting ahead of myself. Let's talk about network policies, policy rules, basic rules. No, it's actually, you know what? It's in the reference. I just remember what I'm searching for. So resource and network policy. All right. So if you come to the documentation website, and actually I can paste this into the chat here. Okay. All right. So if you come down, there is a part which is about selectors. Now, selectors are an expression. So you can write some logics like if this label and this label exist, or if this label or that label exist, or all of these labels, or like global. Or you can actually evaluate like if the key matches something, or like these sort of things, like if a key is inside like these parameters. So you can basically write a dynamic sort of evaluation for your traffic, and that then matches the flow that you're having. Now, one thing to mention here is there are other things that you can do, like a service account match. So you can actually write a traffic to match a service account. You can write application layer policies. For instance, if a GET request is happening for your workloads to a specific address or the whole website, depends on what you want to do. So the limit is actually your imagination. Or if you actually hit a limit, what you can do is come to our GitHub page, and in here, open up an issue. Actually, first search about issue, then open up an issue. And that way, you will get folks who are actually working on Project Calico to either add it or prepare it for the next sprint run. Anyway, that is it for today. I think I talked about most of the things that I wanted to talk. As always, you should be able to find everything that I did inside the GitHub GitHub repository for this Calico Live. It's frozen process Calico Live. I'm gonna put it in the chat. All right. And yep. If you have an idea for the next session, or you want to like co-create one with me, create an issue. Hopefully we'll jam together and talk about Kubernetes or Calico or both. Well, that's it for today. Thank you for tuning in and goodbye.